Greetings, welcome to this new video about mesh analysis method. Solve the problem number 1. Given the electric circuit with R1 20 ohms, R2 10 ohms, R3 5 ohms, R4 15 ohms, and we have two voltage sources V1 30 volt and V2 45 volt. The question now is to calculate the mesh currents IA and IB. Let's go to the solution. Let's start first with mesh 1. By applying Kirchhoff's voltage law in mesh 1, we obtain negative V1 plus R1 IA plus R2 IA minus IB minus V2 is equal to 0. By replacing the resistors and voltages with their numerical values, we obtain negative 30 plus 20 IA plus 10 IA minus IB minus 45 is equal to 0. And if we continue simplifying this equation, we obtain finally negative 75 plus 30 IA minus 10 IB is equal to 0. After we finish from mesh 1, we go to mesh 2. By applying KVL in mesh 2, we can write V2 plus R2 IB minus IA plus R3 R4 IA. By replacing the resistors and voltages with their numerical values, we obtain 45 plus 10 IB minus IA plus 20 IB is equal to 0. If we continue simplifying this equation, we obtain finally 45 plus 30 IB minus 10 IA is equal to 0. Finally, we obtain two equations which are necessary to find IA and IB. Those two equations can be expressed using matrix form as follows, where matrix A is given by 30, negative 10, negative 10 and 30. The first 30 is the coefficient of IA in the first equation, and negative 10 is the coefficient of IA in the second equation. Negative 10 is the coefficient of IB in the first equation, and the last 30 is the coefficient of IB in the second equation, where A is the current vector is given by IA, IB, and finally the vector B is given by 75, negative 45. Now we are going to apply Cramer method in order to solve those two equations. Let's start first by calculating the determinant of matrix A is given by 30 multiplied by 30 minus negative 10 multiplied by negative 10. We obtain 900 minus 100 is equal to 800. Now we are going to define matrix A1. We obtain I1 by replacing the first vector of A by vector B. Then we have A1 75, negative 10, negative 45 and 30. The determinant of A1 is given by 75 multiplied by 30 minus negative 45 multiplied by negative 10. We obtain 2250 minus 450 is equal to 1800. Now we can easily calculate IA is given by determinant of A1 over determinant of A is equal to 1800 over 800 is equal to 225 amps. Now we are going to define matrix A2. We obtain A2 by replacing the second column or the second vector of A by vector B. We have matrix A2 30, 75, negative 10, negative 45. The determinant of A2 is given by 30 multiplied by negative 45 minus negative 10 multiplied by 75 is equal to negative 1350 plus 750 is equal to negative 600. Now we can find IB by determinant of A2 over determinant of A is equal to negative 600 over 800 is equal to negative 0.75 amps. After we finish the calculation, we go to SPICE simulation in order to verify our calculation. Let's go. Here is the circuits done by SPICE simulator. We see here V1 is 30 volt, R1 20 ohms, R2 is 10 ohms, and we have V2 is 45 volt, R3 is 5 ohms, and R4 15 ohms. Let's go to analysis, DC analysis, calculate nodal voltage. We can see here that IA is 225 amps and IB is negative 750 milliamps. And if we want to find the current through the resistor R2 is 3 amps is equal to IA minus IB, that's 225 plus 750 milliamps is equal to 3 amps. Those values are exactly the value we found by calculation. Thank you for watching this video, and if you have any question, do not hesitate to contact me by email or leave a comment under this video, and I will try to answer you as soon as possible. And thank you again, and see you next time in another video about mesh current method. Have a nice time and bye bye.